Okay, now we go for the second part in this chapter, which is deriving a Boolean expression from a truth table. So actually, we can write two forms of logic or Boolean expression. The first one is sum of product or SOP. The second type is product of sum, POS. Okay, we look at our first type, which is sum of product or SOP expression. So what means by SOP expression? So SOP is actually refer to the sum of all product terms when the output is a logic 1. Okay, so based on this first sentence, it shows that we need to find in your truth table, okay, your output that equal to 1. Okay, that is the first key point, okay, for this expression. Okay, so you need to find how many output, okay, in your truth table that equal to 1, and then you need to sum of all product term, okay, when your output that equal to 1. Okay. So what mean by product terms? So product term is formed by you ending the complemented or uncomplemented input variable. So this is how you get your product terms. Okay, so you need to end, okay, the variables. Okay, either your variable is complement or uncomplements. Okay, so actually in a previous subtopic, okay, or the first part, I already explained to you the truth table, yeah, and then the expression, how we get the expression, okay, by using the SOP. Okay. This is example of product term for two variable truth table. Okay, so you know that in your two variable truth table you have 4 combination, right? You have 0 0, 0 1, 1 0, and 1 1. Okay, so this is actually for your input A, and then this is actually for your input B, okay, for your truth table. Okay, and then this is the product term. Okay, so for previous explanation, how you can get your product term? So product term is formed by ending. Okay, you need to perform the operation end. Okay, complement or uncomplemented input variable. Okay, you end for the input variables. Okay, either the input variables you need to complement or not complement. So for the first combination, yeah, your input both are 0. Okay, A0 and B0. Okay, so the product term for the first combination is A bar and B bar, meaning that for both variables you need to complement. Okay, why? Okay, because if you not complement both variables, when you end, okay, the value you will get 0, right? Okay, why? Because your value for A is 0, your value for B is 0. So when you end 0 and 0, you will get 1. Okay? So our objective for this SOP is actually we need to find your output that equal to 1, so that your product term also, when you end, your variables must equal to 1. Okay, so in this case, because both variables the value are 0, that's why both input you must complement. When you complement, okay, the new value here you will get 1 and 1 instead of 0 and 0. So 1 and 1, the value you will get 1. Okay, so this is your A, this is your B. Okay, so for the second value is 0 and 1. Okay, in this case you need to complement your A. Okay, so when you complement your A, your A value will change to 1. Your B is same value because you not complement B, A bar and B, so that's why you will get 1. So your answer also will get 0. Okay, so for the third one, 1 0, so you need to complement your B. Okay, so that's why here you will get 1 and 1 also, so you get 1. And then last one, you don't have to complement both value, so 1 and 1, you will get 1. Okay, this is the product term for two variables. Okay, first thing, before you derive the expression, you need to know the product term. Okay, what are the product terms for that truth table? Okay, and then after that, okay, based on the first definition for SOP, this one, so you need to sum of all product terms, okay, when the output is equal to 1. Okay, so after you know how you can write the product term, so you just sum all the product terms, okay, that the output is equal to 1. Okay, same goes for previous example. Okay, so I already explained to you, okay, this kind of expression. Okay, so if you have three variable truth table, okay, so if you have three variable, which is A, B, C, so first this is the combination of your table, 0 0 1 1 0 1 0 1 0 1 0 1. So here I just want to show how you can get the product term. Okay, so PT, product term. So you know that product term is actually you and, okay, the input variable. Okay, either the variables you complement or not complement. So what is the product term for the first combinations? Okay, because all inputs are 0, so that's why you need to complement all input. Okay, A bar, B bar, C bar. Okay, and then this one is A bar, B bar, and C. Okay, A bar and B and C bar. Okay, A bar and B and C. A, B bar, C bar. A, B bar and C. A, B and C bar, and the last one is A, B, C, right? So this is a product term for three variable. So this is not the SOP, not yet. Okay, I just explained to you what is product term. How can you get a product term? So after this, I will explain to you how you can derive the SOP expression. Okay, by using the product term, okay, that you have listed. Okay, we look at the example. Okay, so this example, okay, derive SOP expression from the OR gate truth table. So you this example, okay, so you are given this truth table, okay, and then based on this truth table, you have two inputs and then one output, which is Y. Okay, and then based on your output, you have 3 y that equal to 1. Okay, so as I mentioned before, for SOP, the key point here is actually you need to determine how many output that equal to 1. Okay, why? Because you need to sum all product term, okay, that output equal to 1. Sorry. Okay, so this is the product term, okay, for this truth table. So no matter what kind of truth table that you have, okay, meaning that the output, okay, based on the output value, so the product term is still the same, right? So the product term are same for all truth table, okay, because we have the same combination. Okay, so tu maksud saya lah kan. So tak kira lah truth table you macam mana sekalipun, maksudnya macam mana tu dari segi output dia lah. Okay. Y ni ada 2, 1 ke, ada 1, 1 ke, tapi input dia still sama, right? So you have the same input, which is you have 4 combination. So that's why your product term is actually same. Okay. So yang membezakan di sini, okay, what is the differences here? Is actually the SOP. Okay. So the SOP, you need to sum all the product term that equal, the output logic is equal to 1. Okay. So this is the product term. So the first is actually A bar and B bar. Okay, dia tak bersambung yang ni. Nampak macam bersambung kan, tapi tak bersambung sebenarnya. Okay. So here there are 3 outputs where output Y is equal to 1. So what is the SOP expression? So SOP expression for this truth table is Y equal to A bar and B. Okay, so we tick which product term that Y equal to 1. So this product term, and this product term. Okay, so refer to this output. So you need to sum. Okay, so you just sum all product terms that the output logic Y is equal to 1. So here, that's why you have 3 product term. So you need to sum, meaning that you need to perform operation of OR. Kan? So tambah tu sama dengan operation OR lah maksudnya kalau kita lukis kan. So that's why this expression is A bar and B plus A and B bar plus A and B. Okay. So this is the SOP expression. So you must remember what means by SOP. First, SOP is actually you sum the product terms when the output logic Y is equal to 1. Okay? And then you must understand what is product term because you need to sum the product term. So you kena faham dululah product term tu apa. Kan? So macam mana you dapat product term tu? Okay? So product term is actually you perform AND operation. Okay? You AND the complemented or uncomplemented input variables. So you kena AND kan, okay, variable tersebut sama ada variable tu you complement ataupun tak complement. Kenapa kita kena complement? Kenapa kita tak perlu complement? It's actually because when you AND for both variables, in this case you have 2 variables, right? So when you AND for both variables, you have to make sure that your result must equal to 1. Itu objektif dia. Kenapa kita ada variable yang kita complement, ada yang tak lah. To make sure that bila kita AND tu, okay, dia akan dapat 1. Akan dapat 1 kat sini bukan bermaksud Y dia. Bukan maksud Y tu, jangan confuse pula. Kan? Jangan confuse pula. Nanti kan you kata, means kenapa A bar and B bar, Y ni kosong? No, it's not relate with the output. It's just the product term, how you can get the product term itu je. Macam mana you nak dapatkan product term. Okay? So output tu berbeza. Okay? Selepas tu barulah you combine. Okay? After that baru you sum. Okay? Sum the product term. Okay, when the output logic is equal to 1. Okay, so this is the first type of the expression, which is the SOP expressions. Okay, we look for the second expression, which is product of sum or post expression. So what mean by post expression? So post expression, yeah, is the product all sum terms when the output is a logic 0. Okay, so for post expression, the key point here is actually you need to look at your output that equal to 0. SOP, you need to look the output that equal to 1. POS, you need to look at the output that equal to 0. Okay. And how you can get the expression for post is actually you need to product all sum terms. Product meaning that you need to multiply. Kena darab lah. That means by product all sum terms. And then here, what mean by sum terms? So sum terms is formed by ORing the complemented or uncomplemented input variables. And so in this product of sums, okay, you need to perform operation OR, okay, to the variable. Okay, either the variable is complement or not complement. That means by sum term. Right. So this is example of sum terms. How you can get the sum terms. So this is your A, and then this is your B for your truth table. Okay, same goes with the SOP. So untuk post pun sama juga. Post ni sum term dia sama je lah, untuk apa-apa apa-apa truth table pun dia akan dapat value yang sama lah, because you have the same combination of 0 and 1, right, in your truth table. So sum terms is actually you perform operation OR between both variables. Okay? And then when you need to complement the variable, okay, so you need to complement the variable when you OR the variables, okay, the result must be equal to 1. Itu maksud dia, bila masa kita nak complementkan dia, bar lah maksudnya kan, okay, supaya bila you perform operation OR, you akan dapat kosong. Okay, so you tengok yang pertama ni, okay, the first value for A and B are 0, 0. Okay, so in this case, because both values are 0, and then when you perform operation of OR, you will get 0, right, by using this value. So that's why you don't have to complement the variables. Okay, so the product term for 0, 0 is A plus B. Okay, so for the second, this is the first one. Okay, for the second combination, which is 0 and 1, you need to complement value B. Okay, because you have to make sure that when you perform the OR operation, you will get result 0. Okay, so if you perform OR operation for this value without you complement B, you will get result 1. Kan, dia akan dapat 1. So tak boleh lah, kita kena jadikan dia jadi kosong. Okay, so for the third combination 1, 0, so in this case you need to complement your A. Okay, so that's why product term here you will get A bar plus B, and then the last combination is 1, 1, so that's why you need to complement both variable. So the sum term for the last combination is A bar plus B. So this is the sum terms for 2 variable truth table. So if you have 3 variable truth table, okay, so if you have 3, so I will show you the sum term, okay, for 3 variable truth table. Okay, so sum term. Okay, so sum term, you need to perform OR operation, right, for the variable. Okay, for the first one, you don't have to complement, okay, because all 0. Okay, so in this case, sum terms, you need to complement if the variable is equal to 1. Okay, so you kena complementkan pada variable yang sama dengan 1. Kalau SOP, product term, okay, you kena complementkan variable yang mana value dia sama dengan 0. Okay, so tu beza ni lah. And then the second one, you will have A plus B plus C bar. Okay, here is A plus B bar plus C. A plus B bar plus C bar. A bar plus B plus C. A bar plus B plus C bar. A bar plus B bar plus C. And then lastly is A bar plus B bar plus C bar. Okay, so this is the product term for 3 variable. Okay, so now I show you the example how we can derive the post expression. Okay, so this is the example of truth table, which is OR gate truth table, and then this is the product sum terms or sebutan jumlah here. Okay, So because in this truth table you only has one output that equal to 0, okay, so that's why your post expression is written as y equal to a plus b. Sebab ada satu je kan? Okay, just a plus b. So if you have more than one, so you need to multiply, okay, for all sum terms, okay, that equal to 0, okay, or you need to product, okay, the sum terms, okay. Alright, so based on the previous example, the Boolean expression for OR gate can be written in two forms, either using SOP or using post. Okay, so maksudnya kat sini, dengan menggunakan satu truth table yang sama, kita sebenarnya boleh derive dua jenis expression. Okay, sama ada you nak gunakan SOP ataupun you gunakan post. Okay, cara kita nak keluarkan expression daripada truth table kamu. Okay, so SOP pun boleh, post pun boleh. Okay, so based on example of riverbank sebelum ni kan, example 3.1, okay, section 3.1, okay, yang buzzer y apa semua tu. So we also can write the expression by using two type of expression, okay, either using SOP or post. So previously yang kita buat sebelum ni, yang buzzer y tu kita gunakan SOP, yeah, a bar, this one, a bar and b bar plus a and b. Okay, other than SOP, we also can write by using post expression. Okay, so how you can write post expression? You must remember post expression, you need to refer to your output that equal to 0 here. Okay, and then you need to product all sum terms. Okay, so what is the sum terms? So sum terms is actually you perform OR operation, okay, for the variable. Yeah, so sum term for the first output that equal to 0 here, so this is the sum terms, which is a plus b bar here, a plus b bar. Okay, and then second sum term is a bar plus b. So this is how you product the sum terms. You put the bracket in a bracket for each sum terms. Kan salah satu cara kita nak darab kan, kita letakkan bracket kan. So ni cara je lah. Okay, kita letakkan bracket untuk setiap sum terms tersebut. Okay, so dalam case ni, maksudnya dalam satu truth table, you kena cari product term dia dulu apa, and sum terms dia. Lepas tu baru you gunakan product term to derive the SOP expression, and then you use the sum terms to derive the post expression. Okay. Alright. So this is the example how we can derive the Boolean expression from the table. So we have two kind of expressions, either using SOP or post expression. So SOP is you sum the product term when the output is equal to 1. So what is product term? So product term is you perform AND operation. Okay, you ending the complemented or uncomplemented input variable. That is for SOP. Second type is post expression or product of sum. So product of sum is actually you product all sum terms when the output logic is equal to 0. What is sum terms? So sum terms, this is a sum terms. So sum terms is you or the complemented or uncomplemented input variables. Okay, so this is how you can derive the Boolean expression from the truth table.